So this is clear, right? Thin layer, thin client model, all the processing will be done into the server. Okay. But in case of fat client model, all the application process will be carried out on the client side. Okay, now look at this picture. So this is very clear to understand the thin and the fat client architecture models. If you look at the thin client model, so this is presentation. So all the presentation will be done through the client, and the server will do all these things. Database management, application processing, all will be done by the server. On the other hand, if you look at the fat client model, so application processing will be done by the client. Only the database update and database management will be done on the server side. Okay, I hope it's clear to you. Now move to the next slide. Okay, look at the examples. This is a client server ATM system. So that means these all the ATMs is the client, and they process, we call the teleprocessing monitor, we call this one. They process all the things through the client and account. There is a server, we call the account server. The customer account will be updated through the account server. So this is we call the fat client model. Okay, now in the client server architecture, we call another type of architecture is called 3-tier client server architecture. So in this architecture, each of the application architecture layers may execute on a separate processor. That means each of the layer will use separate processor for the processing the system. It allows the information transfer between the application server, that is basically the middleware, and the database server to be optimized. So to optimize all this process, they use the middleware server and the database server. It has better performance than a thin client approach, and it is simpler to manage than the fat client approach. All right. A more scalable architecture, as demand increases, extra servers can be added. That means if you want to add extra server, it can be added. That's why we call this is more scalable. It can be added as you want. Extra servers, it can be added to the system. It is used in the web-based application where the processing is handled in middleware. So basically, this is used in the web-based applications where the middleware is using the handling the processing of the system. Okay, now look at this. So this is the client presentation. Go through the client, and then there is a middleware. So all the application, we call this is application server. So all the application will process through the middleware. And then in the database server, database management, that means update the information will be done into the database management server. Okay, look at the example of 3-tier architecture. This is one of the examples that is used into the internet banking system. So you look at here, the left side, you can see the clients, and client. There are 4 clients here, and they connected through the protocol we call HTTPS. What is HTTPS? Hypertext Transfer Protocol Secure. So they go through, that means the protocol will connect with the web server, that is we call the account service provision. So account service provision, that is connected through the each of the client through the HTTP protocols, and this is we call the 2-tier application processing and data management. So it will be done in the web server, and then through the SQL query, the database, in the database server, all the informations will be processing and update into customer account database. So you look at here, so this is client. The second tier 2 is application processing through the web server in the account service for the account service provision, and third is the we call the database server. All the information will be updated based on the information input into the system. So this is tier 3, we call database processing will be done here. Okay. Next, what is the difference between the 2-tier and the 3-tier client-server architecture. So if you look at the picture here, two-tier architecture, that means it's directly linked with the client and the server. So if this is the client, it might be C++, .NET, or Java, etc. The client side, they use this programming language. Then they can be connected with the database server. They can communicate with each other. Okay. If you look at the three-tier architecture, so the client can be connected or through the Internet Explorer, Chrome, or Firefox. Then the middleware, there is a middleware. This is called the application server. Maybe this is IIS, Apache server, Nginx. So they are basically process connect with the client, and then this goes to the database server to update the informations, or from the client, what is the request goes to the server, that will be processed to the middleware, and this goes to the database. And then if the information required from the server, it will process, it will take from the server and come back to the client. Okay, now next one we call the multi-tier client server architectures. So this is, we know already there are 3 tiers server model that can be extended multi-tier variant where additional servers can be added to the system. That means whatever you add, the server, additional server. For example, we have a 3-tier client server model. We can be extended to the 4. That means you can add one more. It can be 5. It can add another one. So this is we call the multi-tier client server architecture. This may involve using a web server for data management and separate servers for application processing and database server. That means it can involve using the web server for data management and separate the server for application processing and data services. That means you can add in the more services. It can be managed by the system. Okay, now look at the advantages client server architecture. Okay, number 1, in terms of advantages, this is improved maintainability. For example, applications are easier to maintain. In that case, application is easier to maintain. If you look at the disadvantage, this is heavily loaded network. That means more distributed processing will be done in the multi-tier server architecture. If you think about the flexibility, developer is free to design and develop various types of components for different layers. That means this is very flexible. Freely design and develop the various types of component for different layers. But if you think about the disadvantage, difficult to program and test due to increased complexity. You can add in a lot of components. It makes the system more difficult to maintain. Scalability. In terms of scalability, new component can be added without affecting the performance of the existing applications. That means if you add in the new components, that will not affect the performance of the application. And the last one is the better load balancing. More evenly distributed processing. That means the application logic distributed between the several servers. Okay, now look at this picture, multi-tier client server architecture. So this is the first one, the tier 1 client, tier 2 database, tier 2 application server, tier 2 they have application server, and then comes to the level tier 3, level 3. So this is tier 3 database server and the tier 3 web server, and the tier 4 again connected with the database server. So if you look at the right side one, so level 1 we have a tier 1 we call the client. Is the client. The level 1 is the client, and this client is linked with we call the level 2 with the server. Level 2 with the server, link with the server, database server, application server, and also tier 2 application server. And then in the level 3 is connected with the server to server, Here is server to server. And the level 4 again is connected with the server to server. So this is the whole architecture. If you look at the architecture, this whole architecture of the multi-tier client-server architecture. Okay, now comes to the another concept is distributed object architecture. So in that case, there is no distinction in a distributed object architecture between the clients and server. So there is no distinction between the client and the server. Each distributable entity is an object that provides services to other objects and receives services from each other. That means one object giving the service to the other objects, and other objects also give the service to the another object. So they are connected with each other through the object. Okay. Object communication is through a middle system called object request broker. This is a software bus. That means this communication will be done through a middleware system. We call this is object request broker. However, more complex to design than client server system. That is more complex because there are a lot of components here. Next, look at this figure. So you see, this is the all of the object architecture. Computer 1, the common services linked with the client. Then second one, computer 2, common services. There is a, in between there is a, we call the communication middleware. Middleware communication is there. So the each is connected with each other and they can give the service with each other through the object component. Correct? So next, what is the advantages of number one? It allows the system designer to delay decision on where and how service should be provided. That means add in the more resources you can add in here because this is very open system. Next one is the system is flexible and scalable. The last one is that it is possible to reconfigure the system dynamically with objects migrating across the network as required. That means you can reconfigure. If you add in the system, you can reconfigure. This is done by dynamically through the object migrating across the network when it's required. Now, the next one is the architecture we call the message queuing architecture. Okay, in the message queuing architecture, the message queuing allows application to communicate by sending message to each other. So they send the message with each other. Messages are queued asynchronously between application and system. So they are queued between the application and the system. The message queues provide a temporary message storage where it does not require an immediate response to continue processing when the destination program is busy or unreachable. That means once send the message, there is a place we call the temporary message storage place. The message will be queued there, and time to time it will be executed. If the system is busy, it will stop for a while, but time to time it will execute properly. In this system, the client applications we call the producer. The client applications we call the producers create messages and deliver them to the message queue. And then on the other hand, other applications we call the consumer. These consumers connected to the queue and get the messages. So the producer send the message, it goes to the message queue, and later on the consumers will get the message from the queue. The producer and the consumers of the message do not need to interact with the message queue at the same time. Messages placed on the queue are stored until the consumer retrieves them. If you look at this picture, message queuing architecture, look at here. This is the left side. This is the actually sender sending the informations. Okay, the producer sending the informations in the message queue. This is the middle part, and the queue will be receiving to the customers through the queue one by one.